negative 2. Okay? And how about when x equals negative 1? What do we get? 2/3 times negative 1 plus negative 1 plus 1 2/3, right? Did that right? 2/3 that, negative 1 plus 1. Did I make a mistake here? Am I using the right formula? Yeah. Okay, so what's this give me? Negative 2/3 plus 0. Okay, so we get that. And then, what else? We have to check at 0. So when x equals 0, what do we get? 0 plus 1 to the 2/3, right? All right, yeah. So that's 1. Right? So what do we get? We get, this is equal to negative 2/3. This is 1, negative 2/3. And this is what? That's more negative than that negative 2/3, right? That's low. And this is what? Negative 7/3. Right? Yeah. Okay, so what do we get? When x is negative 2, we get negative 7/3. So if we're going to make a picture, it's going to look like this. So here it's negative 7/3, just like that. And here it's negative 2/3, which is something like that. And then at 0, it's 1. So, what does this mean? It means that it's like this. What was at negative 2? What was the derivative at negative 2? Where was the cusp? And where was the, something I did not quite right. Where was the derivative equal to 0? When was that? What was when x, I think it was when x equals negative 2. So it means it was kind of flat here. So like this. Then this was derivative, that was a cusp. No, that's where the derivative doesn't exist. So it doesn't quite look like this. Derivative did not exist at negative 1, right? Where was the derivative? Where is the derivative? To do it again? The original function is here. So what's the derivative? 2/3 plus 2/3 times x plus 1 to the negative 1/3. So, now what? So the derivative does not exist at negative 1. Right? This is 2/3 exist at -1. Yeah. So what do we have to do? Okay, we have to take the limit. And x equals, how about, we already did it. When x equals -1. Why doesn't the derivative, what does it mean that the derivative doesn't exist here? Okay, let's think about this. Here's the derivative. So let's ask. So, okay, when x is, so we have this problem at -1, right? We have a problem. The derivative doesn't exist there, right? Okay, so let's ask what's happening to the left of -1. So over here and over here. Okay, let's ask what's happening to the left and to the right of -1. So, to the derivative. Okay, so what happens when we put in something a little less than -1 here? Let's say -1.1. So what do we get? We get a negative number inside here, and then we still get a negative number, right? So we're getting negative numbers there. And how about to the right of -1? Then we have like 0.9. This is positive then, right? So the derivative is, to the left of -1, the derivative is negative. And to the right of -1, the derivative is positive. So, but the derivative is basically infinite here, right? Because at 0, I mean, when the denominator is 0, this is infinite. So, at -1, the derivative is infinite, right? So it's got super steep, right? The derivative, the slope it's infinite, or like vertical. Okay, so what does that mean about this picture? I'm not quite sure. I have to think about it again. So what do we say? It's negative? Well, that doesn't make sense. Maybe it looks like that. It's negative, and looks like that doesn't make sense. Like that doesn't work. Okay, I'm stuck. Okay, I'll get the answer for you next time. When does this due? Well, we can always try reading it, but I think it doesn't work in this browser. Let's see, when does this due? Okay, it's due next week. After next week. Okay, I'll get the answer for this for you. Unless they give us some hint here, but no, it doesn't work. Okay. Let's cheat. Let's try and cheat. I just want to see what it really looks like. over here. I think we don't need that 2/3 part. No, I guess we should do it. Okay, what is this? 2/3 x. How do we do that? Two thirds x plus x plus 1 to the 2/3. Okay, is this right? 2/3 x. Yeah. Okay, that's cheap. Doesn't show you how to do it. Solving. No. I thought it was a graphing calculator. Functions of graphing. Solving. No. I want to graph it. Oh, very good. Right again. Graphic calculator. Oh, here it is. Okay, can you see it? Not too well. Okay, does that make sense to us? What did we say? You said at -2 it was flat, right? So here at -2, it's flat. Okay, does that make sense? We said it's going to -infinity, which could be happening here. We forgot to think about what's going on here, but we only had to check. We only had to check at 0 anyway, so we did that. Okay, and here was the question point. Okay, so why is it like that? What's happening here? What's happening there? So we said what's happening to the derivative? We said as we came to the left, where did I write that? Here. At -1, we said the derivative was not defined. Then we said, what about just a little bit to the left of -1? So not defined means basically infinite. Okay, it's like infinite, because you're dividing by 0. So it's infinite. But it could be negative infinity, or it could be positive infinity. Okay? So then I said, let's check a little bit to the left of -1 and a little bit to the right. And when we did a little bit to the left of -1, I think we probably said that it was, the slope was negative. Okay? So it's negative slope, which means like this, but as you move closer to -1, the slope is going towards infinity. Okay? And on the other hand, to the little bit to the right of -1, we said it was positive, so the slope was positive, but as you move closer to -1, it's going to infinity. So that's what this cusp is. Okay, so the slope is like going towards infinity, negative infinity here, And this way it's going towards positive infinity. Okay? And that's how you get this cusp. Okay, so we were saved by technology. Or no, I was saved by technology. Okay? Does this make sense? Okay. Now hopefully you won't do it that way when you can check your work with that, but you should try and do it yourself first. Okay? Okay. All right, let's go on to, let's see. Okay, so we've done we've done what we needed to do basically for derivatives. So we're pretty far ahead of where we need to be, but let's start with the integrals a little bit. We don't need to do that much in integrals, but anyway, let's just start with that now. Okay? So let's take a 5-minute break to signify that we are changing the subject matter here. So this is a big change. Okay, so what did we do in the course so far? We did the finance math at the beginning, right? Then we spent a long time on derivatives, right? At least 5 weeks, right? And we started with limits because that's how we get to derivatives. And then we did a lot with derivatives, okay? Now we start with a new subject, but it's still related to derivatives, not as different as derivatives were from finance, but it's still a different subject. Okay, so it's integrals. So let's come back at 3:30. Don't disappear. Okay, don't disappear. We all take attendance with something, maybe a quiz or something. So don't disappear. Okay, but you can take a break until 3:30.